Hi, I'm Yannis Roussos, the product manager for the database group, and I'd like to take you through what we're planning to achieve in GitLab 14.8, which is scheduled to be released on February 22nd of 2022. We're working on a lot of interesting topics, so let me get started. Our top priority for 14.8 remains updating GitLab to work with multiple databases. We're supporting the certain group in decomposing GitLab's database to improve scalability. This is one of the most important availability and reliability initiatives in GitLab, as it allows very large instances, like GitLab.com, to keep on scaling by allowing for multiple primary database servers to be used. The primary database server is the bottleneck for any database architecture, as however many replicas we may have, all database writes have to go through the primary database. And there is always a limit on how much we can scale a database server vertically, a limit that we are going close to towards in GitLab.com. So we're adding more and more issues, but we expect all the priority topics to be completed in 14.8 so that we can allow the certain group to continue with their planned release phases. So very quickly, we're going to upgrade all background migrations to work with multiple databases. This is almost done. Update also all regular migrations to work with multiple databases, and finally update our database tooling to support multiple databases. We have added a few more additional things, but what we expect is that by the end of 14.8, GitLab will be able to support multiple databases fully, and then there is the work by the starting group to continue with decomposition. Our next top priority are the batch background migrations. Our plan is to make the batch background migrations framework the standard for all data-related operations and deprecate the existing way of performing them. We anticipate that this will be a major step forward for the stability and availability of GitLab instances of any size, while at the same time making most background data operations complete considerably faster in most cases. That means that once we have this released, we reach general availability, we expect most of data operations to be more stable, less problems, and also faster. So for example, sometimes before upgrading a GitLab instance, we may have to wait for all background migrations to finish. After batch background migrations are released, we expect those to take way less time. So we have a lot more details about what background migrations are, what the current problem is, and motivation, etc. Please check the related epic if you want more details. This will be our ongoing work for a few milestones going forward. Our third top priority is adding a throttling mechanism for large data changes. This is in general, it's not only about background migrations, as we discussed before. So we have had a few database-related incidents that were directly impacted by the rate of updates on specific tables, or in which the rate of updates amplified the problem and caused more incidents. So we feel that implementing a throttling mechanism will address those problems and reduce the risk for database incidents that can reduce the availability of large GitLab instances. Our plan is to evaluate how to implement such a mechanism and start iterating on a first MVC. But the idea there is that while doing everything else that we're doing, here it's also that on any data operation, find ways to throttle the update rate based on how many records have been updated, or make our operations way smarter so that we can check various statistics like dead tuple statistics, heap fetches, other crucial queries running, and work, make decisions based on those things. We may decide to stop the operation, for example, because we say, no, there is a problem. Or we may decide to do maintenance operations. Like, for example, if we see that a lot of cases in Postgres and other systems that use MVCC or other similar types of consistency, you may need to vacuum. So you may say, okay, in order not to affect the system anymore, let me vacuum the table and then I will continue. Or let me pause. For example, an auto vacuum is running on a very large table and we're affecting it. So let's pause and wait. So it's like with batch background migrations, we'll be able to pause and wait when the resources are depleted or the server is overloaded. Here, we take into account even more things. Our next priority is the automated database testing framework. We're shifting left our ability to preemptively find database-related regressions and performance issues by testing all database updates against a production clone of GitLab.com's database. That means that everything that we ship has been tested against the full GitLab.com's database. And that means that we gain confidence that things will work on GitLab.com, and also that things will also work for any instance out there. And with every feature that we add, we move one step closer to GitLab being more performant, and we lower the risks that code may be deployed that will cause incidents and affect the performance and availability of GitLab.com and other self-managed instances. So we have completed our coverage of most database operations, migrations, post-migrations, and everything. The only big thing that we are missing are background migrations. Those are the big jobs that run in the background and update lots of data. This is a non-trivial extension of the automated database testing framework, because background migrations are meant to run for a long period, even for days in GitLab.com scale. In contrast, while testing on a CI pipeline, we want to be able to validate an MR in a few minutes or 10, 15 minutes at max. So we cannot run for 3 days. So we have to figure out ways, and we try to be smart on how to statistically cherry pick and test background jobs, while at the same time offering as much coverage as possible for all scenarios. So for example, there are cases where you run a big data operation over a data update over a large table. Depending on the table and also the way the queries that you have there, you may have performance issues at the start of the table, or at the middle of the table, or at the end of the table. You cannot know beforehand. So we have to be smart on testing jobs all over the range of IDs and the physical space of the table. And the final top priority is adding a database data dictionary. This is not directly relevant to self-managed instances, but it is indirectly. So we want to define the format and a way to label tables by the group that owns them, and later on with additional metadata about the table. So what's the problem here? With more than 400 tables in GitLab's database, that will provide us with the ability to more efficiently respond to database-related incidents or bug and regression reports by self-managed users, because it will allow us to find the group that has the domain knowledge quicker, in a timely fashion, and fix the problem way faster. Finally, a few secondary priorities that most probably we won't have the time to get to them very briefly. So it's first one is reducing the table sizes to at least less than 100 gigabytes, at least for GitLab.com. We use always GitLab.com as our example when we think about updates. What's the problem? The table size is one of the most prominent reasons for underperforming queries, causing timeouts and database incidents. So this will be our very large initiative. It will take us more than a year, I expect. We will have to break all tables, maybe by partitioning or other ways. And but in the end, if we could manage to have all tables at the GitLab.com scale at 10 gigabytes or 15 gigabytes, everything will be way faster, more stable, and the GitLab experience will be snappier, because all queries are at the core of any user interaction with GitLab. Finally, database schema validation. So in general, schema inconsistencies are encountered when a database schema is different than what we expect it to be in GitLab's structure.sql. For example, a date field does not have a time zone, why we expect it to have a time zone. Or there is a missing index, or an index is defined slightly differently than what we expect it to be defined. Those inconsistencies are the major reason for unexpected errors while performing updates both on GitLab.com and on self-managed instances. They directly impact our ability to deploy new updates to GitLab.com or upgrading self-managed instances. And I know with the number of GitLab instances in existence out there, there is a very large number. And especially with some details, like a lot of instances that were upgraded from MySQL to Postgres and may have some additional schema issues, some of them, not all of them. It is very difficult to address all possible schema inconsistencies. But we want to at least address all known inconsistencies, gracefully recover from errors related to inconsistent schema errors, and finally figure out ways to prevent similar inconsistencies in the future, and also make the whole upgrade experience for GitLab way smoother, like a fridge, not thinking about it that much. That's it. Thank you for watching, and talk to you next month.